chickens, today we're going to be multiplying binomial radical expressions. Sweet. Here we go. I know. All right, here we go. First, the binomial to binomial. Here's the deal. Inside to inside, outside to outside. That's the rule. You cannot multiply an outside number to the inside of a radical. So it goes inside, inside, outside, outside. Okay, so here we go. So when you're distributing, the root 2 is the inside and the 6 is on the outside. So when you put together, it's 6 root 2. Hello. And then this would be root 16. Excellent. Right? Inside to inside, outside to outside. Then you add yourself self. Can anything be simplified? Yeah, it can. Root 16 is 4. So this is root 2 plus 4. Done. We're not dividing anything, so you don't need to pull out GCF. Done. What is it? Is it 2 root 6? It's 6. That's a 6. Silly Fleck. Here we go. That's a 6. I'm so silly. Yeah, it's not good. 2, 4, 6. Ha ha. Great question. Are they like terms? The 6 belongs to a root 2 and the 4 doesn't. So, can you add them together? Advents, no. They don't belong together, right? Okay. All right. Yes, love. What does it? The 4 does? Yeah, the 4 belongs to a root 1. The 6 belongs to a root 2. Since they're different roots, they're not like terms. Oh. Yes. It's addition. It's addition. Yes. Okay. Here we go. Too fast. Too fast. Okay. Here we go. First, 14 cube roots of 9 minus 2, right? 2 goes on the outside. Cube roots of 54. 54. Then you ask yourself, self, can any of those be simplified? Which one? Yeah. Now, what do you do with the 2 after you simplify it? You multiply, right? So just don't forget you have to multiply that 2. So this is 14 cube roots of 9 minus 2. It helps if you put parentheses on the outside. Cube roots of 54. 3 and 2. 3 and 2. Hang on. Here we go. So it's 3 cube roots of 2. Yes, that. Where did the 2 come from? Because it's 2 cube roots of 9. So 2 cube root of 9 times 3 cube root of 6 is 2 cube root of 64. So the outside of this thing is a 1. So you multiply outside times outside. 2 times 1 is 2. Okay. Right? And then 9 times 6 is 54. That's not a 2. That's not a 2. I'm just getting excited. I'm getting excited. Yes. I'm a math magician. Math numbers just come out of nowhere. Here we go. Yeah. Clean it top. Clean it top. We're good. Yes. All right. So, hello? Talk to me. 14 root 9 minus 6 root 2. Are they like terms? Then they shall never come together. The end. This is so sad. Oh, no. Okay? All right, chicken time. Me gusta la chicken musto. Mucho? Mucho. There we go. I'm going to move it a little bit. Move it a little bit. All right, here we go. First, outer, inner, last. So first is 3 plus root 2 plus 3 root 2 plus, it's root 4, which is 2. Excellent, because root beer in a square glass beer. Yay! All right, simplify 3 plus 1 root 2 plus 3 root 2 is 4 root 2. These are like terms, so this is 4 root 2 plus 2. The 3 and the 2 are now like terms, so clean it up, clean it up. Plus 4 root 2. Yay! Oh, where's the chicken? Seriously. Ah! like it. Am I going too fast? Oh, excellent. Excellent. All right. Ooh. Ooh. Okay. Here we go. Yeah. 3 root 6 plus. Now what? Combine which ones? You can't. The 12. The 12 can be simplified, right? First of all, combine. Look for combinations. That's great. But root 6 and root 2 are not the same company, so you can't combine it. The only thing that can be simplified is root 12. So this is 12 plus 3 root 6 plus 4 root 2 plus 2 root 3. Does anything combine? Heavens no, done. Ta-da! Yay! Miss Black, why do we have to simplify to 12 in the first place? Because it might have. You never know. Keep everything as simplified as possible. Yeah. Oh, good. We have some cubes now. You okay, Miss Small? Yeah. You good? Okay. Okay. Oh, yeah. Let's do some cubes. Let's do some cubes. Oh, chicken. Yes. Okay. Here we go. All right. Talk to me. 10. Minus, right? Yeah. Minus cube root of 8. Ooh, it's a blue chicken today. Hey. All right. Now what? Where? Simplify where, bud? Cube root of 8. See, you've done it so many times, you could just see it. That's a 2. That's a 2. So it's 10 plus 2 cube roots of 2 minus 5 cube roots of 4 minus 2, which combines with the 10. So final answer, 8. Woo! Woo! I love it. I love it. Okay. Okay. Here we go. Oh my gosh. That's a good one. It's a good one. Talk to me. 4. Question.
So like if it's the same number inside the radical,
Yes.
still like square or
When you're adding them, you just add the coefficients. So like if they're like term, you just add the coefficients. Let's get to one. Okay? Okay. Here we go. 4. Woo, woo, woo. 1 times 3 minus 3 roots 7 plus 8 root 7. There you go, Adrian. It's coming. Minus 6 root 49, which is going to be 7. Spoiler alert, right? Green chicken. All right, because green means go. 4. Negative 3. Yes, like terms. Like terms. So plus 5 root 7 minus 6 times 7. 6 times 7 is, yes, love? It is negative 38 because it's 4 minus 42, which is negative 38 plus 5 root 7. Ah! Okay. It can be 5 root 7 minus 38 or the other way around. It doesn't. Yeah. I'm good. Commutative property covers you. Yay? Yay, yay. Okay. Ooh. Okay. One more good one. Then we're going to get to the F word. Fractions. Okay. Here we go. MM. Oh, fractions. 15 minus cube roots of 4 minus 9 cube roots of, so 15 minus 15 cube roots of 4, because that's nothing, plus 9 cube roots of 2 minus 9 times 2, which is 18. So 15 minus 18 is negative 3 minus 15. Ooh, right. I feel like you've done this before.
Nope.
Have you? No, it just makes sense, right? Yeah? Yes, Maddie. Then it still would not be like terms. But if it was a square root, okay. So if you're multiplying a cube root to a square root, what do you do when you multiply with exponents? Yeah, power to a power, you multiply again, right? Yeah, I won't throw anything like that just yet. But good question. Good question. You won't see that for your initial problems. And you probably won't see it on the SOL, honestly.
Oh.
Yeah, no. Yeah, yes, love. You really want to see it, don't you? Okay. Okay.
No, I don't.
Oh, no. You asked. So let's do the square root of 5 times the cube root of 5, right? Yay? Okay. So I have to prove it to you in the way I know how to prove it to you, right? So you know how you index is you divide into the exponent? So one way you can write this is 5 to the 1/2, because you divide the 2 into the 1, right? And then this would be 5 to the 1/3. Yay?
What?
Yeah.
Oh yeah,
Not quite the 6th root, because here's what do you do when you multiply? What do you do with exponents? Add them. So this will be, get ready, 5 to the 1/2 plus 1/3. No, that's not how you add fractions. You need a common.
Oh no.
It's all good.
I took it home. Alright.
Common denominator is 6. So this needs to be multiplied by 3. This needs to be multiplied by 2. So this is actually 5 to the 5/5 or 6. Sorry about that. 5 to the 5/6. Because the common denominator of 2 and 3 is 6. Yeah. To get a common denominator for 2 and 3, the least common multiple is 6, right? So to get 6 from a 2, you need to multiply by 3, and vice versa. And whatever you do bottom, do to the top. So that's actually 5 or 6. This is actually next lesson. So let's hang on. Yeah. Eventually, but not like, yeah, I know. It's all good. No, I teach this in regular algebra 2 also. Yeah, it's okay. It's okay. It'll be fine. All right, but this is good. It's forward thinking. All right. Oh, fractions. Here we go. Yeah. One of my favorite, sorry, love. Here we go. One of my favorite factoring techniques is dose. Yay? If you remember dose, you remember that A plus B times A minus B is equal to A squared minus B squared, right? This is a dose, right? These two right here are called conjugates. Repeat after me, conjugates. Right? If you multiply by conjugates together, then you have a difference of squares, which makes it super easy. Here's when you do it. If you see a plus or minus in the denominator and there's a radical, you don't want that radical denominator. So you see the radical is root 3. It's not enough just to multiply by root 3. Because if you do that, you're still going to have root 3 at the bottom because you have to distribute to the 6. So to get rid of that root 3, right, you have to multiply by the conjugate of this, which is going to be 6 minus root 3. And whatever you do to the bottom, that's right, do to the top, because really you're just multiplying by 1. Right? Something divided by itself is 1. So here's what you got. At the top, you have 11 times 6 minus root 3. At the bottom, you have A squared minus B squared. 6 squared minus root 3 squared. Yay? And that'll get rid of the radical for you. Sweet. P.S. We do this in trig all the time. All the time. Here we go. At the top, just distribute. So we've got minus over 36 minus 3, which is 33. So we've got 66 minus 11 root 3 over 33. The GCF is 11. So final answer, 6. Ta-da! Done. Yay? The GCF of 11 is 1. So when you 11 divided by 11 is 1. So that's gone. Yay? No. When you're taking like the square root of something, now the depends on your technicality. So the fourth root you should technically put plus or minus, but there's more than just 2 answers. So if you forgot the plus or minus, I wasn't going to penalize you. Because a fourth root would have been 4 answers. Plus or minus only takes care of 2, which means the other 2 would have been imaginary, blah, blah, blah. Yeah. Yes, love. Uh-huh. Thanks. Yes. Cannot. Yes. That's right. Because that's a root 3, not a regular 3. Yay? Yay. Yes, love. No, not this quiz. Not this quiz. Yay? Okay. Let's do it again. We'll do it again. Ha! Root 5 plus root 2. Very good. Top and bottom. All right. So the top will have 3 root 2 times root 5 plus root 2. And root 5 squared minus root 2 squared. It's always minus because it's a dose every time. Yay? Okay. Here we go. 3 root 10 plus 3 root 4 is true. Over 5 minus 2. Clean it up, clean it up. What do you see? Five minus 2 is, this is definitely 3 down here, right? 3 root 4 is, it's going to be 6. Yeah, oh, we could divide out by 3. We could. So if you divide all the 3's, you have a 10 plus root 4, but root 4 is just 2. So final answer, root 10 plus 2, or 2 plus root 10. Something, something, dark side, something, something. Yay? All right. Did you get 10 before you leave today? That's what you have to do. Take a look at the, did I finish it? Or is that it? Yeah, I did. Yay. All right, here we go. Take a look at the top of your notes. It tells you where to start all 10 today before you leave, and then no Terea. You're welcome. Yeah. Let's go.